Hello! The last time we discussed about the perspective view, about the vanishing points, the horizon lines, and how the real-life parallel lines in a perspective view are going to one same point, which is called vanishing point. Okay, well, now, because we found out the response that F3 is taller than E3 and that we understood how the perspective works, we'll try to do the exact same thing on the Da Vinci's sketch. Okay, so what we want to do is that knowing this side dimension, this pole dimension, and this side dimension, we want to find out the other dimension of the poles, of the holder, and so on. So for this, I will import in Sketchbook this sketch. And what I want to do is to draw the lines as I did in the previous video. So I will select the base as a reference and I will start putting the points and there. Okay, I put it a line and now I will draw it. Good. And now I will go to the other side edge and I will align again those points and I will draw the line. And here, as you can see, is the first vanishing point. Let's find out the second vanishing point if it exists. And for this, I'm gonna draw this line. And if I'm just dragging the line, we can observe that the second line is parallel with the first one. Okay, so if I will go with this one, so they are parallel. That means we have only one vanishing point. The problem with the sketch is that it looks like it was hand sketched, so it's not very straight, but we will use this projection as the main plane. We'll have one single vanishing point, and those other lines are parallel. What I can do now, after finding the vanishing point, I will select again the perspective guidance. I will select one point mode, and I'm gonna put my point where the intersection of the line is. Awesome. Good. And now what I can test is with another color. I want to test to see, yes, those are the lines that I designed. And now I need to do something. So, as I told you, I will mark with red the areas that I know the size. So this side is known, this size is known, this size is known, and this size of the pole is known as well. Good. What I want to find out, and I will mark with green, I want to find out the size of this pole, the size of this part of the holder, the size of this pole as well, of this pole, and of, I'll mark with another green color, of this round part. Well, okay, again, we have the same problem with the trees. We cannot do like this to the pole that we know. We need to project it on the pole plane, okay? Because this green part is further than us and the pole is closer than us. So we need to translate the green line into the red line's plane. So how can we do this? I will select the yellow color. I need to use this point and use the perspective guidance to intersect the red line, which is in the same plane at this red line of the pole. And again, the top of the object. And where the bottom intersects with the red line is the point where I need to go up. So this green, okay, is this size. So only now I can measure this and compare it with this size, okay? This one already is on the plane. I will just do this line. So this one is already on the front plane. This one, again, needs to be projected. And it will be on this intersection, okay? And this line, again, needs to be projected and will be on this intersection. So here, similarly here. Good, but because I want those to be the same size, I went a little bit to, okay, and this will be the point. So what I found out, that those poles have the same size, this pole has the same size, and they are here, okay? So by measuring those lines, I can find out what is the measure of the object. Also, I want the size of this. So what I can do is to continue. So this will be the size of the round object. Awesome. What I can do now is to find out the thickness of the objects by doing this projection. So these sides, these parts will show me the size of the poles and of the other objects. Okay, good. And last but not least, we need to select another color and show these sides. And this one, the pole as well. And I think the pole ends here. Awesome. Well, as you can see, now I can get the dimension of this part. I can get the dimension of the thickness of the pole, the thickness of this part, the thickness of the other pole, and so on. So I'll save the image and see you into the next video to show you how, using Fusion, you can find out the dimensions. See you into the next video.